Babak Hodjat, the CTO of Cognizant. A round of applause as you enter. Thank you.
Hi, everyone. My name is Babak, and I'm here to talk to you about the ITU AI for Good Project Resilience. And in order to talk about that, I have to take you back to a painful time that we all lived through. The time where there was a lot of chaos, a lot of pain, a lot of unknown. We actually called it the coronavirus. We didn't even know what it was called just yet. And what we really craved at that point was to know what's going to happen. What is this thing about? I wish we had like a crystal ball to be able to tell what's next. And usually our crystal ball is AI, but it was failing us. It was nowhere to be seen, and in fact, it got some bad press. So how can we help? As AI folks, as analysts, as data scientists, we set out to try to predict what's going on, as epidemiologists, obviously, as well. And is there a way for us to be able to tell what's going to happen next? And this resulted in many forecasting models. But there was a problem. Epidemiological models, which are simulation-based, require a lot of values that are basically assumptions that are built into these models. And at the beginning of an epidemic in which we knew very little about the virus and how it acts, we didn't have those assumptions. And so they weren't quite useful. The other problem that we had was that even with those assumptions in there and the predictions, these predictions were not in the presence of actions that would be taken. So almost immediately after a predictive model came out, it was useless because of course we were taking actions. Of course we were trying to do things to stop the spread of the virus. What we really needed was some system to tell us what to do, what kind of policies to put in place, at what stringencies, and how can we be timely and still not break the bank? How can we not have an economic impact while containing the epidemic? Now, when you think about it, if you want to put together a schedule of, let's say, a 3-month schedule, daily schedule, of various different stringencies, let's say 12 different policies at different stringencies, this is a very, very large search space. There are many, many different permutations of policies you can put in place. In fact, the number is so large that it's just unfathomably large. So just having a prediction is not enough for us to be able to tell what is the policy or set of policies that we need to put in place. It's not an easy problem. The other thing that exasperates this is we can't go out and just try these different policies and actions out in the real world to see which one works and how effective it is. It's just not reliable. This is not practical. It's costly, and it's risky. The other thing also is things keep changing on us. Our reaction to these policies were changing. People, whether or not they were actually adhering, was changing. We were coming up with new ways to tackle. You know, at the beginning, people were saying, yeah, you don't need to wear masks. Then, oh yeah, everybody wear masks. And don't wear cloth masks. And, you know, so we were trying various different things out, and we were coming up with various different ideas. So how can we keep up with all of this? Most importantly, how can we come up with policies and actions that are both improving the state of the number of cases, like reducing the number of cases and containing the pandemic, while also not breaking the bank, basically. So what we set out to do is we set out to build a system like this, a predictor that was looking at the number of cases, information about the localities, also looking at the various different policies that were in place in the various different geographies. The good news was, or bad news I guess, was that this pandemic was hitting different countries at different times, at different intensities, and countries were dealing with it differently. And that diversity was actually really good. That was the kind of data that we needed to build into this model to make the prediction. But of course, as I said, prediction alone is not enough. We ended up building a system where you could click on a locale, a geography, a region, and also determine what balance of economic impact versus containment you were looking for. And this system would actually produce a set of policies and actions to take, a schedule over the next 3 months to take in reasonable detail. And it would also give you a prediction, in this case the orange line, of what you could achieve if you set these policies in place, and what would happen if you don't, or if you continue on with the policies that you already have. So this system was actually up and running in May of 2020. When you think about it, the shutdowns in the US at least happened in March of 2020. So very, very quickly, with not a lot of data, we were able to actually set a system up that was quite effective. And it garnered the attention of some geographies and regions, which ended up some of them actually using it. We then thought, wait a minute, there are so many teams around the world working on the same problem. Can we harness that? Can we bring that in and try to find the best possible predictions and the best possible prescriptions, the decisions? So we did an X Prize. It was the world's fastest X Prize, from the point of coming up with what it was to running it to announcing the winners. The pandemic was actually raging as we were doing this. And it met with incredible participation. We actually got more than 100 teams competing and submitting from many different countries. But then this was a competition. As we were running the competition, we realized that these predictor models that we're using could be ensembled together. We can actually put them together and get a better prediction than the contributed predictors. We could also take the actual optimizations, the decision recommender models, and use them as a basis for creating a decision recommender that would take the best of all these various different recommenders and give us recommendations that were better than all of these recommendations that were very locally focused, yet were usable elsewhere. So we had happened upon this method where various different teams around the world could come up with different models using whatever approach that worked for them, focused on their locale, but we could actually bring those in, distill them, train upon them, and build decision augmentation systems that were useful not just for the folks that were contributing, but others that might not have been able to have that sort of resource at their disposal. And so that led to Project Resilience. Can we build a place for teams that are already working on problems that locally impact them, but these problems have a global implication? Can we bring them together and have them contribute data, contribute models for predictions, for prescriptions, and build something where the resulting system was better than the sum of its parts? And that project kicked off about a year ago. We have a number of volunteers around the world helping on it. And already we picked climate. That's an obvious project. And for climate change, we looked at the data around land use change. And it turns out that you can indeed create a data-driven ML model for predicting climate pollutants from land use change and the change and difference in CO2 emissions as you make policy changes on land. And we actually put together a UX for this. You can click on any region around the world and decide what balance of economic impact, the number of changes you want to make, versus the CO2 emissions that you can afford for that particular region. And it will give you some suggestions as to how to make those land use changes. And also it gives you a lot of facility to run what-if scenarios, to lock various different changes that you just simply can't afford to make, and focus on others. It's very interactive, and that allows for trusting it. And ultimately, our vision is to build a system in which we can bring all these stakeholders, not just the data scientists and folks that are collecting the data, but also folks that are going to end up using it, the regulators, people who have the money and are interested in contributing. So that's our vision for Project Resilience. We need help. We don't have enough people. We need volunteers. If you can help us with any of these or more, please come see us. We're Project Resilience as part of ITU. I just want to leave you with one last thought, which is, at the end of the day, all this data, all this AI is in the service of decision making. That's what we do day in, day out at various different levels. And we've been focused too much, I think, on insights and just producing those reports so that the poor decision maker, who is in fact lost in a sea of data and analysis, to make a decision, these decisions are not simple to make. What if we were actually able to collectively come up with a roadmap, with suggestions, interactively, to allow these users, these decision authorities, to make the best decision based on the data available so far and make it adaptive? Wouldn't the world be a better place if we could do that? So please volunteer and help us make the world a better place. Thank you very much.